In this lecture, we can learn about how addition and subtraction operation can be performed in the case of octal number system or with octal numbers. First of all, octal addition can be performed in the same way we are performing the addition of decimal numbers. I will just read out these rules and we can familiarize these rules by adding more examples. First of all, we need to add the digits in each column in decimal and convert this sum into octal. That is, we have to add the digits coming up in corresponding columns while by treating them as decimal numbers and get the result is converted into octal form. Then record the octal sum term in that column and carry the carry or forward the carry to the next column. We can see with an example. So we want to add 4, 5, 6 to the base 8 plus 1, 2, 3 to the base 8. So we know that the base or radix of octal number system is 8. So we are writing just like this 4, 5, 6 plus 1, 2, 3. Then we can perform the addition operation. 6 plus 3. We are taking the first digits in the first column, rightmost column. Addition operation is starting from the rightmost column. Just like any other operation, 6 plus 3 is equal to 9. But be careful, there is no digit with or symbol 9 in the octal number system. So we are treating this digit as decimal numbers 6 plus 3. So the result is 9 also in the decimal number system. So its base is 10. So we have to convert 9 in the decimal number system to its equivalent number in the octal number system. We have already seen how we can convert a number in the decimal number system to octal. Yes, we can use the method of repeated division. So we are going to divide 9 with 8. So the 9 in the decimal system need to be converted with its equivalent number in the octal number system. So we are dividing 9 with 8. So 8 here and 9 is written over here. Then we can check in how many times 8 is included in 9. Only one time. So 1 is written over here. So 1 into 8 is 8, but 9 is equal to 8 plus 1. So that 1 is written as carry or remainder. So 1 into 8 9 1 into 8 8 plus 1 is equal to 9. 1 into 8 1 and with the remainder 1. So the answer is 1 to the base 8. So even though we are adding 6 plus 3, the result is 9. We cannot write it as it is. We need to find its equivalent octal number, that is 1 1, and we will write the rightmost digit over here and forward the carry, that is 1 to the next higher bit position. This one denotes the carry. So next we need to add these 3 bits, 5 plus 2 plus 1. So 5 plus 2 plus 1 is 8. 8 in the decimal number system. Again, 8 is not there in the octal number system. In octal, the symbols are available from 0 to 7 only, since its base is 8. So we need to convert 8 to its equivalent octal number. So we are using the method of repeated division with 8. 1 into 8 is 8 itself. So the remainder is 0 and the answer is 1 0. So 8 in the decimal system is equal to 1 0 in the octal number system. So 0 is written over here and 1 is forwarded to the next higher bit position. So we need to add these 3 numbers here, 4 plus 1 plus the carry. So the answer is 6 to the base 10. Since 6 is less than 7, the equivalent in the octal number system is 6 itself. So, or we can, 6 itself. So 6 to the base 10 is equal to 6 to the base 8 in the octal number system. So the answer is 6. So we can write it as 456 plus 123 to the base 8 is equal to 601 to the base 8. Next, we will see another example. Add 327.54 to the base 8 to 665.37 to the base 8. So we can write the numbers by following the rules of aligning the bits. So 327.54 plus 665.37 to the base 8. Starting from the rightmost bit, we have to add this 4 plus 7. 4 plus 7 is 11 to the base 10. But This is in the decimal number system. We have to convert into octal number system. So 11 divided by 8. So 1 into 8 is 8 plus 3 is equal to 11. So the octal equivalent of 11 is 13. So first 3 is written over here, and with a carry 1, it is forwarded to the next higher bit position. So we need to add these three numbers, 5 plus 3 plus 1. So the answer is 9 to the base 10, or decimal number system. Again, we need to convert this 9 to its equivalent number in the octal number system. 9 can be divided with the 8. So 1 into 8, 8 plus 1. So answer is 1 to the base 8. This one is written over here, and that the left one is forwarded as a carry to the next higher bit position. So here. So next we need to add these three numbers, 7 plus 5 plus 1. So the answer is 7 plus 6. So 13 to the base 10. That 13 need to be converted into its equivalent in the octal number. So division with 8, 1 into 8 is 8 plus 5. So 15 to the base 8. That 5 is written over here with a carry 1, and it is forwarded to the next higher bit position. 6 plus 2 plus 1. So the answer is 9 to the base 10. We have already seen that the octal equivalent of 9 is 11. So that 1 is written over here with a carry 1, that is forwarded to next higher bit position. So 6 plus 3 plus 1. So 9 plus 1 is 10 to the base, and 10 or decimal number system. To find its equivalent in the octal number system, we are dividing it with 8. 10 divided by 8. So 1 into 8 is 8 plus 2. So the answer is 12. So that 2 is written with a carry 1. Since there are no bits in the leftmost bit position, the carry is also appended to the end. So the answer is 327.54 to the base 8 plus 665.37 to the base 8 is equal to 1315.13 to the base 8. Next, we will see another example. Consider 162 to the base 8 plus 537 to the base 8. We can write the numbers one below the another. So we are adding these two numbers, 7 plus 2, the answer is 9. We have already seen that the octal equivalent of 9 is 11. So 1 is written over here with a carry 1. So in the next step, we have to add these three bits. 6 plus 3 plus 1 is equal to 10. Its octal equivalent is, we can compute in this way, or we have already seen in the previous slide, it's 12. So 2 is written over here with a carry 1. So 5 plus 1 plus 2, that is 7 in the decimal number system, which is equal to 7 in the octal number system also, since there are 8 symbols ranges from 0 to 7 in the octal number system. So its answer is 721 to the base 8. Don't forget to write the base while writing the result. Then next we will see octal subtraction. In this lecture, we are discussing the direct method. Octal subtraction can also be performed using 7's complement and 8's complement method that we can discuss in another video. This video is octal subtraction in the usual way. That is, octal subtraction can be done in the same way. Yeah, we are performing decimal subtraction. So consider, subtract 16.478 from 20.14. So we have to subtract 16.47 from 20.14. So 20.14 is written over here minus 16.47. So we can start from the rightmost bit. Again, remember that the base is 8. Then, what is the borrow? Consider a decimal number, that is 88 minus 19. Two decimal numbers, and we are going to subtract. Is it possible to subtract 9 from 8? No. What we will do? We will take a 1 from the next higher bit position. From here, we will move forward a 1. Take a we will take a borrow. So 1 is taken from this bit position. So this 8 is reduced to 7. So the 8 will become 18, right? Since the 1 in this position, when it shifted to this bit position, become 10. So 10 plus 8 is 18. So 18 minus 9 is 9. 9 plus 9 is equal to 18. Then 7 minus 1 is 6. So the answer is 69. in the case of decimal number system. The same method can be applied in the case of octal number system also, but there is a difference. The base is 8. So what about the borrow? We can discuss. The borrow is 8. How it comes? We can check. Okay, here 4 minus 7. It's not possible. Reason is that 7 is greater than what 4. So we have to make or take borrow from the higher order bit position. So here is a 1. I'm taking a 1 from this bit position and it is forwarded to this place. So here the power of 8 is 8 raised to minus 1. Here the power of 8 is 8 raised to minus 1. Here the power is 8 raised to minus 2. When a 1 is taken from this position and forwarded to this position, that 1 will become 8. Since there is a power difference of 1, say 8 raised to minus 1 here and 8 raised to minus 2 here. So that 1 will become 8 here. So here we have taken a 1. So that number become 0. Here it is reduced to 0 and here it become 8. So we have to add 8 plus 4, that is 12. 12 minus 7, 5. 5 plus 7 is equal to 12. Just like here, okay, we have forwarded a 1 to this bit position. That 1 will become 8 here. The reason is that there is a power difference. Here 8 raised to minus 1 and here 8 raised to minus 1. You can simply remember that the borrow is 8 in the case of octal number system, 10 in the case of decimal number system, 16 in the case of hexadecimal number system, and so on. So we need to add 8 plus 4. So 12 minus 7. Answer is 5. Here is 0 only. We have already taken 1 from this bit position to this bit position. So this 1 is reduced to 0. 0 minus 4 is not possible. So what we can do? We have to take borrows from the higher order bit position. But unfortunately here is 0. So we can't take from this bit position. So we can take from this bit position. So from 2 we are taking a 1 to this position first and from here to here. So this 2 is reduced to 1. We have taken a 1 from. This 1 become 8 in this bit position. So here at first it become 8. From that 8, we are taking a 1 to this position. So here 8 minus 1, that is 7. Here the 8 is reduced to 7. Then 8 in this position become 8. 8 plus 0 already. We have taken a 1 to this bit position. So here 0 only. 8 plus 0 is 8. 8 minus 4, the answer is 4. This is how 4 comes here. Then here 7 minus 6, 1. Here 1 minus 1, the answer is 0. So 20.14 to the base 8 minus 16.47 to the base 8 is equal to 1.45 to the base 8. I think it's clear to you. Since the base or radix of octal number system is 8, the borrow is 8. Since moving from higher order bit to a lower order bit, there is a single jump. The value is increased by the power of 8. So this 1 will become 8 in the next lower bit position. So we can see another example. 257 minus 165. So 257, 165. Here I have written the powers of 8 also. 8 raised to 0, 8 raised to 1, 8 square. So base is 8 and borrow is 8. So 7 minus 5. We can simply subtract. 7 minus 5 is 2. Then 5 minus 6. It's not possible. Reason 5 is less than 6. So we are taking a 1 from this place to this. So 2 minus 1. The answer, this 2 will reduce to 1. So this 1 is forwarded to this bit position. So from here to here, that 1 will become 8. So 8 plus 5. 8 plus 5 is 13. Then 13 minus 6, 7. That 1 minus 1, 0. So the answer is 0.72 to the base 8. I think it's clear to you. We are taking a 1 from higher order bit position and that 1 will become 8 in the immediate right bit position. The reason is that the power difference, the power is increasing towards this direction and decreasing towards this direction. Or you can simply remember that the borrow is 8.